The starship Horizon's whisper emerged from faster-than-light travel, with a subtle shimmer of quantum displacement, its massive hull gleaming under the distant starlight. Captain Zarak settled into the command chair, her iridescent scales shifting with a mixture of boredom and mild irritation. Another routine planetary survey awaited, another potentially unremarkable world to catalog in the endless galactic database. The ship's primary sensor array began its methodical sweep of the blue-green planet, cutting through atmospheric layers with precision-tuned quantum scanners. Most junior officers found these initial surveys tedious, but Zarak appreciated the methodical nature of preliminary exploration. Each world held potential, even if most proved disappointingly mundane. Junior sensor technician Kira made her first critical observation 47 standard minutes into the initial scan. Her manipulation of the holographic display caught the attention of the senior research analyst, a veteran named Emkstor, who had surveyed over 200 planetary systems during his career. "Something unusual," Kira murmured, her slender digits dancing across the translucent interface. Unusual was an understatement. The atmospheric readings defied every predictive model in the ship's comprehensive database. Emkstor leaned closer, his sensory tendrils extending slightly, a gesture of professional curiosity. "Explain your interpretation," he requested, his voice carrying the measured tone of someone who had seen countless planetary anomalies. The holographic display shifted, revealing complex layers of atmospheric data, where most developing civilizations showed clear signs of environmental stress, toxic accumulation, greenhouse gas buildup, radioactive contamination. This planet demonstrated something entirely different. "The atmospheric composition is recovering," Kira explained, her voice a mixture of excitement and professional restraint, "but not through standard ecological stabilization methods we've observed in other developing systems." Captain Zarak's attention shifted from her routine data review. In her decades of exploration, she had learned that unusual often translated to potentially significant. She approached the sensor station, her movements deliberate and precise. The holographic display expanded, revealing intricate networks of data points. Unlike the chaotic environmental signatures typical of industrializing worlds, this planet showed something closer to a self-regulating system. Technological interventions were happening, but they weren't destroying the environment. They were healing it. "Cross-reference with our comprehensive planetary development database," Zarak instructed. Her voice carried an edge of professional curiosity that suggested more than mere routine investigation. Emkstor's experienced hands moved across secondary interfaces, pulling historical comparative data. His sensory tendrils began to pulse, a physiological response indicating genuine surprise. "Captain," he said, his typically monotone voice carrying an uncharacteristic hint of excitement, "the atmospheric recovery rate is unprecedented. This isn't gradual improvement. This is systematic, intentional environmental restoration." The bridge of the Horizon's whisper fell into a moment of collective silence. Planetary surveys rarely produced moments of genuine surprise. Most developing worlds followed predictable patterns of industrial expansion, environmental stress, and potential ecological collapse. This world was different. Kira continued her analysis, her enthusiasm barely contained. The technological signatures suggest a globally coordinated effort, but not through centralized control. It's more like a collaborative network. Each intervention builds upon previous efforts, constantly adapting, constantly improving. Captain Zarak recognized the significance immediately. Collaborative global technology was rare among developing species. Most civilizations struggled with territorial conflicts, competitive economic models, and short-term thinking that prevented comprehensive planetary management. "Prepare a preliminary report," she instructed, "but include a notation for comprehensive verification. This requires a detailed investigation." The junior sensor technician's hands continued their delicate dance across the holographic display. Each movement revealed another layer of the planet's remarkable environmental story. Technological interventions that looked chaotic from a distance revealed themselves as an elegant adaptive system upon closer examination. Something extraordinary was happening on this small blue planet, and the crew of the Horizon's Whisper was about to discover just how extraordinary humanity truly was. Little did they know that this routine survey would become a turning point in their understanding of planetary development and of intelligent life itself. The research laboratory aboard the Horizon's Whisper hummed with an unusual energy. Holographic displays covered every available surface, each one showing a different aspect of the mysterious blue planet's atmospheric composition. Dr. Elena Ramirez, the lead atmospheric researcher, had been awake for nearly 36 standard hours, her dedication consuming her completely. Most researchers would have taken a rest cycle by now, but something about these readings defied every established scientific model she had ever studied. The atmospheric data was not just unusual, it was revolutionary. "Computer, run another comparative analysis," she muttered, her fingers dancing across multiple holographic interfaces simultaneously. Each movement triggered complex algorithms that compared the planetary data against thousands of known civilizational development profiles. The senior research assistant, a crystalline being named Exenal, watched with growing fascination. "The recovery patterns are non-linear," he observed, his translucent form shifting with intellectual excitement. "Traditional ecological restoration models cannot explain these interventions." What they were seeing was nothing short of miraculous. Most industrializing civilizations followed a predictable path: rapid technological development, followed by environmental degradation, and then, if they survived long enough, potential ecological stabilization. This planet had compressed that centuries-long process into mere decades. The atmospheric data told a story of systematic, intelligent intervention. Carbon capture technologies worked in concert with renewable energy networks. Artificial intelligence systems managed ecological interventions with a precision that seemed almost organic. Each technological solution adapted and improved upon previous iterations, creating a planet-wide restoration mechanism. Dr. Ramirez zoomed into a particular data cluster, her breath catching. "Look at the communication patterns between these technological systems," she said, her voice a mixture of scientific precision and genuine wonder. "They're not just managing environmental recovery. They're learning." The holographic display expanded, revealing intricate networks of data points. What appeared chaotic at first glance revealed itself as an incredibly sophisticated, self-correcting system. Technological interventions were happening simultaneously across different sectors: energy production, industrial processes, agricultural systems, all working toward a single coherent goal of planetary restoration. Thexenal's crystalline form pulsed with analytical energy. "The collaborative nature is most intriguing," he noted. "These interventions are not centrally controlled. They appear to be a global, distributed effort." Indeed, the data suggested something unprecedented. Unlike most developing civilizations that struggled with territorial conflicts and competitive economic models, this species had developed a truly collaborative approach to planetary management. Each technological solution was shared, improved upon, integrated into a wider ecological restoration strategy. The research team had begun with low expectations. Preliminary scans had suggested a planet under significant environmental stress. Industrial processes, technological expansion, resource extraction, all the typical markers of a civilization on the brink of ecological collapse were present. But something extraordinary was happening. "Computer, generate a comprehensive intervention timeline," Dr. Ramirez instructed. The holographic display shifted, revealing a chronological map of technological and ecological interventions. What emerged was a story of remarkable resilience and innovation. Each ecological challenge was met not with resignation, but with creative, adaptive solutions. Artificial intelligence systems predicted potential environmental stress points and developed preemptive technological interventions. Industrial processes were continuously redesigned to minimize ecological impact. Exenal's analytical algorithms worked overtime, comparing these findings with thousands of planetary development profiles. The recovery rate exceeds all known galactic standards by a factor of 17.3, he reported, his crystalline form vibrating with the excitement of scientific discovery. Dr. Ramirez knew that their preliminary report would challenge everything the Galactic Research Council understood about developing civilizations. This was not just another planetary survey. This was a fundamental reimagining of how intelligent species could interact with their homeworlds. As the final computational models completed their analysis, a profound realization settled over the research team. They were looking at something more than just environmental restoration. They were witnessing a species that had transformed its greatest technological challenges into opportunities for planetary healing. The Horizon's Whisper continued its methodical survey, its sensors continuing to unravel the remarkable story of a small blue planet and the ingenious species that called it home. Something extraordinary was waiting to be discovered. The simulation chamber aboard the Horizon's Whisper thrummed with energy as the research team attempted to unravel the complex environmental management systems of the blue planet. Holographic projections danced around them, each representation a fragment of a much larger, more intricate puzzle. Senior computational analyst Marcus Chen stood at the center of the chamber, his hands moving with practiced precision across multiple interactive interfaces. Years of experience in planetary systems analysis had prepared him for complex challenges, but nothing could have prepared him for the unprecedented ecological management he was now studying. "The adaptive algorithms are unlike anything in our database," he muttered, more to himself than to his colleagues. The computational models defied traditional understanding of technological intervention. Dr. Liana Okoro, the team's lead systems theorist, leaned in closer. Her dark eyes reflected the shifting holographic displays, catching every nuanced data point. "It's not just an algorithm," she observed. "It's a living system of technological intervention." What they were witnessing was nothing short of a planetary immune system. The technological networks of Earth functioned like a complex, self-regulating organism. Each industrial process, each energy production system, each agricultural intervention was connected through an invisible web of intelligent communication. Marcus manipulated the holographic display, expanding a particularly intricate data cluster. "Look at the recursive learning patterns," he said, his voice a mixture of scientific excitement and genuine wonder. "The system doesn't just respond to environmental challenges, it anticipates them." The computational model revealed layers of complexity that challenged everything the research team understood about technological development. Most civilizations develop technologies in isolated, competitive sectors. This planet had created something entirely different, a globally integrated system of environmental management. Renewable energy networks communicated with industrial production systems. Agricultural technologies shared data with urban infrastructure planning. Artificial intelligence platforms continuously analyzed and predicted potential ecological stress points, developing preemptive interventions before problems could fully develop. Dr. Okoro's fingers traced the intricate data pathways. "It's a collaborative intelligence," she explained to Zugzanil, the crystalline research assistant, who observed with growing fascination. Not centralized control, but a distributed network of continuous improvement. The simulation revealed how each technological intervention built upon previous solutions. An industrial process would be modified to reduce environmental impact. That modification would be shared globally, analyzed by artificial intelligence systems, and further refined. The result was a constantly evolving approach to planetary management. Computational comparison complete, the chamber's artificial intelligence announced. The holographic display shifted, revealing a stark comparison between this planet's ecological management and thousands of other developing civilizations. The differences were profound. Most planetary systems showed a predictable pattern of technological development. Rapid industrial expansion followed by environmental degradation. Some managed to stabilize their ecosystems after centuries of struggle. A rare few achieved a sustainable balance. This planet had compressed centuries of ecological challenge into mere decades of innovative intervention. Marcus Chen zoomed into a specific data cluster representing urban infrastructure. What appeared chaotic from a distance revealed itself as an elegant adaptive system. Energy production, waste management, transportation networks all worked in concert, continuously optimizing themselves. The collaborative approach is the key, Dr. Okoro noted. Each technological solution is immediately shared, analyzed, and improved upon. There's no competitive barrier to ecological innovation. Hexagonal's crystalline form pulsed with analytical energy. The global communication networks enable unprecedented technological collaboration, he observed. Where most civilizations struggled with territorial conflicts and proprietary technologies, this species had created something revolutionary. The simulation continued to run, revealing layer after layer of sophisticated environmental management. Artificial intelligence systems predicted potential ecological stress points with remarkable accuracy. Technological interventions were developed, shared, and implemented with a speed that defied traditional understanding of industrial development. As the research team watched, the holographic display told a story of remarkable planetary healing. What should have been a world in environmental crisis was instead a testament to collaborative innovation, adaptive technology, and a species-wide commitment to ecological restoration. The Horizon's Whisper continued its survey, its sensors capturing every nuanced detail of this remarkable planetary system. Something extraordinary was waiting to be fully understood, a new paradigm of technological and ecological interaction that would challenge everything the Galactic Research Council thought they knew about developing civilizations. The restoration algorithm continued its elegant, persistent work, healing a planet, one technological intervention at a time. The visual reconstruction chamber aboard the Horizon's Whisper hummed with anticipation. Holographic projections began to map the intricate technological landscape of the blue planet, revealing a network of innovation more complex than any the research team had ever encountered. Dr. Catherine Rodriguez, the team's lead visualization specialist, manipulated the control interface with practiced precision. Her fingers danced across translucent displays, peeling back layer after layer of planetary technological infrastructure. "This isn't just technology," she muttered, more to herself than to her colleagues. "This is a living, breathing ecosystem of innovation." The holographic display expanded, showing how different technological systems communicated and collaborated. Energy production networks seamlessly integrated with transportation systems. Agricultural technologies shared real-time data with urban infrastructure planning modules. Each system was not just functional, it was adaptive, learning, and continuously improving. Senior analyst George Martinez leaned forward, his eyes wide with professional fascination. "Look at the communication protocols," he said, pointing to a particularly intricate network of data pathways. "They've created a global technological nervous system." What emerged was nothing short of a planetary-scale collaborative intelligence. Unlike most developing civilizations that develop technologies in isolated, competitive sectors, this species had created something revolutionary. Technologies didn't just coexist, they actively communicated, shared, and improved each other. The visualization revealed how a solar energy innovation in one continental region could be analyzed, modified, and implemented globally within weeks. An agricultural breakthrough in one area would be immediately studied, adapted, and applied to different environmental conditions across the planet. Hexagonal, the crystalline research assistant, projected additional analytical overlays. "The collaborative efficiency is unprecedented," he observed, his translucent form shifting with intellectual excitement. "Zero proprietary barriers. Maximum knowledge distribution." Dr. Rodriguez zoomed into a specific technological cluster representing urban infrastructure. What appeared chaotic from a distance revealed itself as an elegant adaptive system. Waste management technologies communicated with energy production networks. Transportation systems optimized themselves in real time, reducing environmental impact with each iteration. "It's a technological symphony," she explained to her colleagues. "Each system plays its part, but they're all connected to a larger, more complex composition. The most remarkable aspect was the speed of innovation. Traditional galactic models suggested that technological development happened incrementally, with significant breakthroughs occurring over generations. This planet demonstrated something entirely different, a rapid, collaborative approach to technological evolution. Machine learning algorithms worked in concert with human creativity. When an environmental challenge arose, the response was not bureaucratic or slow. Instead, a global network of researchers, technologists, and innovators would immediately begin collaborative problem-solving. George Martinez pulled up a comparative analysis, his professional demeanor giving way to genuine wonder. "Look at the innovation velocity," he said, highlighting a graph that showed technological adaptation rates. "They're solving planetary challenges at a speed that defies all our predictive models." The visualization continued to expand, revealing layers of technological complexity. Artificial intelligence systems predicted potential environmental stress points with remarkable accuracy. Technological interventions were developed, shared, and implemented with a speed that challenged everything the research team understood about industrial development. Exynol's analytical algorithms worked overtime, comparing these findings with thousands of planetary development profiles. The collaborative network increases technological adaptation speed by a factor of 7.2. He reported, his crystalline form vibrating with scientific excitement. Dr. Rodriguez zoomed out, showing the entire planetary technological network. What had initially looked like chaos resolved into a breathtaking display of interconnected innovation. Each technological system was a note in a larger, more complex melody of planetary management. "They're not just developing technology," she said softly. "They're reimagining how technology can interact with their world." The Horizon's Whisper continued its survey, its sensors capturing every nuanced detail of this remarkable technological ecosystem. Something extraordinary was waiting to be fully understood, a new paradigm of technological collaboration that would challenge everything the Galactic Research Council thought they knew about developing civilizations. The technological symphony played on, a constant, adaptive composition of innovation, collaboration, and planetary healing. The conference chamber of the Horizon's Whisper fell into a profound silence. Holographic displays surrounded the research team, each projection telling a story more extraordinary than the last. Captain Zarak stood at the center, her iridescent scales shifting with a mixture of professional discipline and genuine fascination. Dr. Elena Rodriguez stepped forward, her presentation interface humming to life. Decades of planetary research had prepared her for complex discoveries, but nothing could have anticipated the findings before her. "Comparative analysis complete," she announced, her voice steady despite the groundbreaking nature of her report. "The environmental recovery rate of this planet defies every known galactic standard." The holographic display expanded, showing a complex web of planetary interventions. Each data point represented a technological or ecological breakthrough. What should have been a chaotic mess of industrial development was instead a meticulously managed planetary restoration project. Senior analyst Marcus Chen manipulated additional interfaces, bringing up comparative charts. "Look at the recovery metrics," he said, highlighting specific data clusters. Most developing civilizations take centuries to stabilize their environmental systems. This planet has compressed that process into mere decades. The research team had begun their survey expecting to find another typical developing world, a planet struggling with the consequences of rapid technological expansion. Instead, they had discovered something revolutionary. Exynol, the crystalline research assistant, projected additional analytical overlays. His translucent form pulsed with intellectual excitement as he broke down the numerical comparisons. Environmental restoration velocity exceeds known galactic standards by a factor of 17.3, he reported. The presentation revealed layers of unprecedented planetary management. Carbon capture technologies worked in perfect synchronization with renewable energy networks. Agricultural systems communicated with urban infrastructure planners. Each technological intervention was not just a solution, It was part of a larger, adaptive planetary healing mechanism. Dr. Rodriguez zoomed into a specific data cluster representing global technological collaboration. The most remarkable aspect is not just the speed of recovery, she explained, but the collaborative approach. There are no territorial barriers to ecological innovation. Most galactic civilizations develop technologies in isolated, competitive sectors. Proprietary restrictions and territorial conflicts often prevented comprehensive environmental solutions. This planet had created something entirely different, a globally integrated approach to planetary management. Captain Zarak listened intently, her professional demeanor giving way to genuine wonder. The preliminary report would challenge everything the Galactic Research Council understood about developing civilizations. Marcus Chen pulled up a comparative timeline, showing how quickly this planet had addressed environmental challenges. Traditional models suggest centuries of struggle, he said, highlighting the dramatic differences. This civilization has transformed potential ecological disaster into a global restoration project. The holographic displays continued to expand, revealing layer after layer of sophisticated environmental management. Artificial intelligence systems predicted potential ecological stress points with remarkable accuracy. Technological interventions were developed, shared, and implemented with a speed that defied traditional understanding of industrial development. It's not just technological innovation, Dr. Rodriguez emphasized. It's a species-wide commitment to planetary healing. Sentinel's analytical algorithms worked overtime, comparing these findings with thousands of planetary development profiles. The crystalline researcher projected additional contextual information, showing how unique this approach truly was. The research team had discovered something more than just an interesting planetary survey. They had found a fundamental reimagining of how an intelligent species could interact with its home world. Captain Zarak understood the significance immediately. Prepare a comprehensive report, she instructed, but include a notation for comprehensive verification. This requires a detailed investigation. As the presentation concluded, a profound realization settled over the research team. They were looking at something more than just environmental restoration. They were witnessing a species that had transformed its greatest technological challenges into opportunities for planetary healing. The Horizon's Whisper continued its methodical survey, its sensors continuing to unravel the remarkable story of a small blue planet and the ingenious species that called it home. Something extraordinary was waiting to be fully understood, a new paradigm of technological and ecological interaction that would challenge everything the Galactic Research Council thought they knew about developing civilizations. The Galactic Research Council's central chamber buzzed with tension. Holographic projections flickered with data from the Horizon's Whisper's comprehensive planetary survey, casting ethereal light across the faces of the most senior researchers in known space. Captain Zarak stood at the center of the chamber, her presentation interface humming with carefully compiled evidence. Years of diplomatic experience had prepared her for challenging conversations, but nothing could have prepared her for the response to this particular report. "We are not discussing a typical developing civilization," she began, her voice calm and precise. "We are witnessing a fundamental reimagining of planetary development." The senior council members represented dozens of advanced civilizations. Most had spent centuries perfecting their technological and ecological management systems. They listened with a mixture of professional skepticism and growing intrigue. Dr. Marcus Chen stepped forward, bringing up a series of comparative charts. Traditional galactic models suggest that developing civilizations follow a predictable pattern, he explained. Initial technological expansion, followed by environmental stress, then potential stabilization over centuries. The holographic display shifted, revealing the Earth's unprecedented trajectory. Where other civilizations showed long periods of environmental struggle, this planet demonstrated rapid, collaborative restoration. Senior researcher Vegsnell, a crystalline being from the Andromeda Collaborative, leaned forward. "The recovery rates are statistically impossible," he observed, his translucent form shifting with intellectual excitement. "Yet the data is irrefutable." Captain Zorak understood the significance of this moment. This was more than a planetary survey report. This was a challenge to fundamental assumptions about technological and ecological development. The presentation continued, revealing layers of global collaboration that defied traditional understanding. Technological innovations were not hoarded or protected by proprietary restrictions. Instead, they were immediately shared, analyzed, and improved upon by a global network of researchers, engineers, and innovators. Look at the communication protocols. Dr. Chen emphasized, highlighting intricate data pathways. This is not just technological development. This is a species-wide collaborative intelligence. Most galactic civilizations develop technologies in isolated, competitive sectors. Territorial conflicts and economic barriers often prevented comprehensive solutions to planetary challenges. This civilization had created something entirely different, a globally integrated approach to technological and ecological management. The council chamber fell into a profound silence. Dr. Elena Rodriguez brought up additional contextual information. We're not just looking at environmental recovery, she explained. We're witnessing a species-wide commitment to planetary healing. Sixnal, the research team's analytical assistant, projected additional statistical overlays. Technological adaptation speed exceeds known galactic standards by a factor of 7.2. He reported, his crystalline form vibrating with scientific precision. Captain Zorak watched the council members carefully. She recognized the mix of emotions playing across their faces: professional skepticism, growing wonder, and a dawning realization that everything they understood about developing civilizations might need to be reconsidered. Holographic displays continued to expand, revealing layer after layer of sophisticated planetary management. Artificial intelligence systems predicted potential ecological stress points with remarkable accuracy. Technological interventions were developed, shared, and implemented with a speed that defied traditional understanding of industrial development. Senior researcher Vixenol manipulated additional interfaces, diving deeper into the comprehensive data. The collaborative efficiency is unprecedented, he muttered, more to himself than to the others. As the presentation concluded, a profound shift began to settle over the Galactic Research Council. They were looking at something more than just an interesting planetary survey. They were witnessing a fundamental challenge to their understanding of technological and ecological development. This requires a comprehensive investigation, the council leader announced, her voice carrying the weight of institutional curiosity. We cannot dismiss these findings. The Horizons Whispers research team had done more than complete a routine planetary survey. They had discovered a new paradigm of planetary management, a collaborative, adaptive approach that reimagined the relationship between technology, ecology, and intelligent life. Something extraordinary was waiting to be fully understood. The technological symphony of a small blue planet continued to play, a constant, adaptive composition of innovation, collaboration, and planetary healing that would challenge everything the Galactic Research Council thought they knew about developing civilizations. The diplomatic transport vessel Starbridge Horizon approached the blue planet with a sense of anticipation unlike any previous exploratory mission. Aboard the ship, a diverse coalition of researchers, diplomats, and scientific specialists prepared for humanity's first comprehensive galactic review. Dr. Elena Rodriguez stood at the observation deck, her eyes fixed on the approaching planetary sphere. Years of research had led to this moment, a pivotal point of first comprehensive diplomatic contact. Approaching planetary interface, the ship's navigation system announced. The vessel's quantum communication arrays began their delicate dance of initial contact protocols. Senior diplomatic coordinator Jin Wei reviewed the preliminary communication strategies. Most first contact scenarios followed strict, carefully choreographed protocols. This mission was different. The research from the Horizons Whisper had completely upended traditional diplomatic approaches. The planet's global communication networks responded with remarkable speed and openness. Where most developing civilizations would be cautious, defensive, or secretive, this species demonstrated an unprecedented willingness to share knowledge. Dr. Marcus Chen monitored the initial communication streams. "They're not just responding," he observed to his colleagues. "They're actively inviting collaborative investigation." Hexenal, the crystalline research assistant, projected additional analytical overlays. Translucent data streams danced around the diplomatic team, revealing the intricate global communication networks that had fascinated researchers during previous surveys. Diplomatic protocols gave way to something more remarkable. The humans didn't just prepare presentations or carefully curated information. They opened their entire planetary research infrastructure, inviting comprehensive review and collaborative analysis. Research stations around the planet began transmitting comprehensive environmental and technological data. Each transmission was not just a report. It was an invitation to collaborate, to understand, to learn together. Senior Coordinator Wei recognized the significance immediately. "This is not a typical first contact scenario," she announced to the diplomatic team. "This is a species offering global collaboration as a first gesture of communication." The planetary networks revealed something extraordinary. Technological innovations were not protected by proprietary restrictions. Instead, they were immediately shared, analyzed, and improved upon by a global network of researchers, engineers, and innovators. Holographic displays filled the diplomatic vessel's conference chambers. Each projection told a story of planetary healing, technological innovation, and collaborative problem-solving that defied traditional galactic understanding. Dr. Rodriguez brought up additional contextual information. "They're not just sharing technology," she explained. "They're inviting us to participate in their approach to planetary management." The research teams from multiple galactic civilizations began receiving comprehensive data packages, environmental restoration techniques, technological innovation protocols, collaborative research methodologies. All were being shared with unprecedented openness. Hexenal's analytical algorithms worked overtime, comparing these findings with thousands of first contact scenarios. Communication efficiency exceeds known diplomatic standards by a factor of 5.9, the crystalline researcher reported. What emerged was more than a technological exchange. It was a fundamental reimagining of interspecies collaboration. The humans weren't just presenting their achievements. They were offering a comprehensive approach to planetary and technological development. Research stations from dozens of star systems began receiving invitations. Collaborative research projects were proposed, spanning environmental restoration, technological innovation, and ecological management. Senior Coordinator Wei recognized the profound moment unfolding. "This is not a typical first contact," she repeated to her colleagues. "This is an invitation to reimagine how intelligent species can collaborate." The diplomatic vessel's communication arrays continued to hum with activity. Each transmission revealed another layer of the humans' remarkable approach to global challenges. Technological innovations, environmental restoration techniques, collaborative research methodologies, all were being shared with remarkable openness. Something extraordinary was happening. A small blue planet was challenging everything the Galactic Research Council understood about developing civilizations, about technological innovation, about collaborative problem-solving. The Starbridge Horizon continued its approach, its sensors capturing every nuanced detail of this remarkable first contact. Researchers from multiple star systems watched with growing wonder, understanding that everything they thought they knew about planetary development was about to change. The technological symphony played on, a constant, adaptive composition of innovation, collaboration, and planetary healing that would reshape galactic understanding forever. The Global Collaborative Research Center in Geneva stood as a testament to humanity's unprecedented approach to planetary challenges. Researchers from multiple galactic civilizations moved through its halls, their presence a living demonstration of a new era of interspecies cooperation. Dr. Elena Rodriguez walked alongside Captain Zorak, their conversation a delicate dance of scientific discovery and diplomatic understanding. The initial survey that had begun years ago had transformed into something far more significant than anyone could have anticipated. It was never about being the most advanced, Elena explained, gesturing to a holographic display showing global environmental restoration projects. It was about being the most collaborative. The display told a remarkable story. Technological innovations that originated in small research stations in various parts of the world now powered ecological restoration projects across multiple planetary systems. What had begun as humanity's local solution to environmental challenges had become a galactic approach to planetary management. Senior researcher Zegznal projected additional analytical overlays. The crystalline being's translucent form shifted with continuous fascination. Collaborative innovation efficiency continues to exceed all predictive models, the researcher noted. The Galactic Research Council had undergone a profound transformation. What had begun as a routine planetary survey had become a fundamental reimagining of technological and ecological development. Humanity's approach challenged every existing model of civilizational progress. Captain Zarak reflected on the journey. The initial survey had been routine. Another developing world, another potential catalog entry. Instead, they had discovered a species that approached planetary challenges with a unique blend of creativity, collaboration, and persistent innovation. Research stations from dozens of star systems now worked in concert. Environmental restoration techniques developed on Earth were being adapted to planetary ecosystems across multiple star systems. Each innovation built upon previous discoveries, creating a rapidly expanding network of ecological knowledge. Dr. Marcus Chen brought up a comprehensive timeline of technological development. "Look at the innovation velocity," he said, highlighting the exponential growth of collaborative research. Traditional models suggested incremental progress. We're seeing geometric expansion of technological capabilities. The humans had created something unprecedented. A global, and now galactic, collaborative intelligence. Technological innovations were not protected or hoarded. They were immediately shared, analyzed, and improved upon by a network of researchers that now spanned multiple star systems. Senior diplomatic coordinator Jin Wei observed the ongoing research with a sense of wonder. "We didn't just share technology," she explained to a group of visiting researchers. "We shared an approach to solving planetary challenges." Holographic displays throughout the research center told a continuous story of planetary healing, environmental restoration projects, technological innovations, collaborative research methodologies. All were being shared with remarkable openness. Zegznal's analytical algorithms continued to process the ongoing data streams. Collaborative problem-solving efficiency continues to increase, the crystalline researcher reported. Each new challenge becomes an opportunity for collective innovation. The Horizons Whisper research team had done more than complete a routine planetary survey. They had discovered a new paradigm of planetary and interspecies management, a collaborative, adaptive approach that reimagined the relationship between technology, ecology, and intelligent life. Dr. Rodriguez looked out over the research center, watching researchers from multiple civilizations work together. What had begun as a small blue planet's local solution to environmental challenges had become a galactic model of collaborative innovation. "We're not just solving problems," she often told visiting researchers. "We're creating a new way of understanding how intelligent species can work together." The technological symphony continued to play, a constant, adaptive composition of innovation, collaboration, and planetary healing that had reshaped galactic understanding. Captain Zarak understood the profound nature of this moment. What had seemed like a routine planetary survey had become something far more significant. Humanity had not just developed innovative technologies. They had created a new approach to understanding collective problem-solving. As the day concluded, researchers from multiple star systems continued their collaborative work. Each breakthrough, each shared innovation, represented another note in the ongoing symphony of galactic cooperation. Something extraordinary had been discovered. A small blue planet had shown the galaxy a new way of understanding technological and ecological development. The collaborative potential of intelligent life continued to expand, one shared innovation at a time.